This is Majid. I'm going to show you my solar system sun tracker. Here is my power supply. It supplies about 12.7 volts with about 0.5 amp for the sun tracker. As you can see, the frame is quite simple. It needs just a little bit of handiwork and welding. The main frame is sitting on two hinges, two pivots. One of them here is a ball joint, which is a part of a suspension and steering systems for the car. Attached to these two bars, and the third bar is used to forbid motion back and forth. And here's the sensor of the sun tracker. I have attached a black tape on the other side in order to move the system backward away from the sun. As you can see, the actuator is moving very slowly. By the way, the actuator is supposed to work on 36 volts. Well, I'm supplying it with 12 volts. You can see the black mark is going inside the weather seal. Here is the attachment of the actuator. The rear pivot I've used a part of a pipe union. It's about 3/4 inch, and attached to these two supporters, the green one, as you can see, on the chassis. The sensor is temporarily attached, as you can see, by electric tape. And here is the electronic circuit of the sun tracker. It contains two relays to reverse the polarity of the motor. And here is the wires. You can watch the magnetic spinning wheel to operate the reed switch, because this actuator is originally designed to rotate a satellite dish. So I do not use this feature. I do not need it. It is still running because of the black tape on the sensor. It's almost sunset time, as you can see. I'm blinding the waste part of the sensor to force the system to move to the east, so that you could watch the spinning motor of the actuator and a very slow motion upward. And you can see the green LED indicating that the motion is for the east, while the red LED, the same LED, indicates motion to the west. Here I am lifting the tape from the sensor so that it will move to the west. As you can see, the red LED is lit. And the actuator is moving downward. Here's my connection wires. Um, it's two pairs. Each one is about 0.5 square millimeters cross section. I'm going to use two of these wires. One of them is to connect the supply from controller to the actuator, and the other is to make an extension from sensor to the controller. Since I have an intention to use the electronic controller indoor. Here's my complete system after painting it with anti-rust paint on the top roof of my house. Here is a beam to hold the sensor I've welded to the structure. This sensor is connected to the electronic controller by an extension wire, both for about 15 meters long. The wires are temporarily connected. Here is the sun tracker controller. I've used it indoor. You can see the extension of the sensors, and you can see the red LED is blinking, indicating that the actuator is moving. And I do not like this successive and rapid connection of the relay. I have installed the sun tracker right above the PWM solar controller, and here is my watt meter reading about almost 13 amps. I've used the MPPT before, but since we have a very hot climate, it was useless comparing with the high price of it with respect to the PWM solar controller. And here is my APC UPS. I'm using it as an home inverter. I bought the sun tracker console from Alibaba.com, and they didn't supply me with any manual, so I'll try to move this pod to eliminate the problem of successive clicking of the relays. Thank you for watching. Best regards from Baghdad.